What if I told you that ancient civilizations figured out one of Earth's most complex astronomical phenomena 12,000 years before the Greeks supposedly discovered it? And not only did they know about it, is it possible they measured it with precision that wouldn't be matched again until the modern era? The most notable evidence is carved in stone at the world's oldest megalithic structure. But mainstream archaeology has been looking the other way for decades. Today we're going to examine what happens when you apply rigorous scientific analysis to this ancient knowledge, and why the results may fundamentally change how we think about human consciousness and capability. Welcome back to the Ancestral Mind. If you're new, I'm Jeremy, a PhD in cognitive neuroscience, and here I examine archaeological evidence through an evolutionary neuroscientific lens to reconsider how ancient peoples thought and viewed their world. So let's start with the astronomical phenomenon in question, precession of the equinoxes, which is one of Earth's slowest dances, a wobble so gradual you'd likely never notice it in a single lifetime. Picture a spinning top starting to wobble as it slows down, which occurs due to gravitational forces. Earth does something similar, but here the motion is a result of the combination of our planet's tilt at about 23.5 degrees and the gravitational pull of the sun and moon tugging on our equatorial bulge. From Earth's surface, this creates several observable effects that skywatchers can notice and ancient astronomers very well may have. Every night, the constellations drift ever so slightly, about 50 seconds of arc per year. More dramatically, over decades and centuries, they would have seen the pole star change and the constellations marking the seasons slowly shift position. But could ancient peoples really have detected something so subtle? How sophisticated do you need to be to detect precession? Not as sophisticated as you might think. For hunter-gatherers and early farmers whose lives depended on tracking seasonal changes, recognizing solstices and equinoxes would have provided enormous survival advantages by marking where the sun rises and sets on these special days relative to prominent landscape features or bright star patterns. After several generations of careful observation, you'd notice something strange. The sun's position relative to the star patterns on these crucial days keeps shifting in the same direction. The heavens appear to be slowly turning. This discovery that the cosmic clock itself is shifting would have been both fascinating and crucial for long-term planning. They could predict climate cycles, plan agricultural activities, and develop sophisticated navigation systems. On land to track prey, avoid predators, and locate food sources, and over water to scout and explore new lands. Modern science calculates the duration of precession to be 25,772 years for Earth's axis to complete one full wobble cycle, what Plato called the Great Year. And keep that number in mind because what ancient peoples calculated might shock you. While mainstream history credits the Greek astronomer Hipparchus with discovering precession around 150 BCE, his estimate was 1 degree of axial rotation every 100 years, giving a total cycle of 36,000 years. But when we examine ancient mythologies along with archaeological evidence, we find something extraordinary. Ancient cultures had already calculated that it takes roughly 72 years for every 1 degree shift along the ecliptic. The precise number is 71.6 years. This sacred number, 72, appears again and again across cultures worldwide, embedded in their most important mythologies and architectural designs. And 72 years per degree gives us 25,920 years for a complete cycle. So think about that. It means that the ancient estimate was 99.4% accurate, while Hipparchus was only 72% accurate. Ancient peoples were 39% more accurate than the Greeks, who supposedly discovered precession 12,000 years later. So how did ancient cultures achieve this level of precision? And why hasn't mainstream archaeology taken any of this evidence seriously? Some of our answers may be carved in stone at Göbekli Tepe, a vast megalithic complex in southeastern Turkey. Mainstream carbon dating makes it at least 11,600 years old, meaning the site predates Stonehenge by over 6,000 years and the Egyptian pyramids by 7,000 years. Dr. Martin Sweatman from the University of Edinburgh applied rigorous statistical analyses to Pillar 43, which is also known as the Vulture Stone. What he found challenges everything we thought we knew about ancient astronomical knowledge and more. His work suggests that the animal symbols on this pillar aren't random. They likely correspond to the relative positions of constellations around the setting sun on the summer solstice, as they would have been seen about 13,000 years ago. And the probability of the animal figure matches and arrangement occurring by pure chance, including the additional figures at the top of the pillar, is just 1 in 140 million. So this isn't speculation. This is a highly statistically significant finding. Even more interesting is how this date aligns right with the onset of the Younger Dryas cooling period. This suggests it wasn't just an astronomical observation, it may have been a memorial to a cosmic catastrophe that mounting evidence suggests devastated landscapes worldwide, triggering a 1,200-year mini-ice age. I've covered the complete analysis of Pillar 43 in a dedicated video, so check the description for the link. But crucially, this evidence suggests Paleolithic peoples not only understood precession, they quite possibly were using it to create precise historical records. And the Younger Dryas impact hypothesis? That's getting its own video soon. Evidence for this global catastrophe is growing quickly. It seems tied to ancient wisdom traditions worldwide and may have sparked a mental shift that changed the path of civilization as we know it. It also wiped out countless species, including megafauna, and left a sharp drop in male genetic variability, clear signs of a massive human population impact. Back to the notion of an ancient calendrical system, Göbekli Tepe isn't an isolated case. 4,000 years later, at Çatalhöyük, perhaps the world's first city, we find the same astronomical system being used. At that site, archaeologists discovered 4 distinct types of animal shrines throughout: bears, aurochs, rams, and leopards. But again, it seems these likely weren't random choices. They correspond exactly to the 4 constellations marking the solstices and equinoxes around 7000 BCE. The bear goddess, depicted as a crawling figure with a prominent circle on her belly, represents Virgo, the constellation behind the sun on the summer solstice. The circle is likely the sun itself, using the same symbolic system found at Göbekli Tepe. The auroch skulls represent Capricornus at the autumn equinox. The ram heads mark Aries at the winter solstice, and the paired leopards represent Cancer at the spring equinox, even showing the constellation's symmetrical shape. Sweatman notes that while most of the ancient zodiac symbols are the same as we use today, it's worth recognizing slight adjustments, which I'll likely discuss in future videos. This gives us potentially 4,000 years of continuous astronomical knowledge, a sophisticated system for tracking precession that was preserved and transmitted across millennia. This isn't primitive mythology, it's advanced science encoded in spiritual symbolism. But the evidence extends far beyond Turkey. In their groundbreaking work, Hamlet's Mill, MIT scholars Giorgio de Santillana and Hertha von Deschend documented how ancient mythologies worldwide encoded precession knowledge. The sacred number 72 appears in Norse mythology, Hindu cosmology, Egyptian traditions, and Maya calendars. It's even built into the dimensions of the Great Pyramid at Giza. These cultures, separated by thousands of miles and years, all preserve the same astronomical constant. The mythological traditions themselves stretch back nearly 10,000 years, suggesting this knowledge network was operating across the globe much earlier than previously imagined. And this was simply as far back as de Santillana and von Deschend could trace it. So is it possible it went back even further? We do know that they encoded this knowledge in stories of cosmic mills, world trees, and grinding mechanisms, all metaphors for the slow rotation of the celestial sphere, with the mechanisms breaking when the pole star changed. The precision of transmission is remarkable, and we're discovering evidence at even older sites, Paleolithic locations, that may push this astronomical tradition back even further. Again, that's a video for another day, so keep an eye out for it. But why hasn't mainstream archaeology embraced any of this evidence? We're looking at strong statistical significance, mathematical precision, and cross-cultural validation spanning thousands of years. If nothing else, it all warrants significant follow-up investigations. The resistance may be more than scientific, maybe institutional. Yeah, this new data challenges established timelines, but what's really driving the resistance? Perhaps it's because accepting this evidence leads to uncomfortable questions about our current view of human history, of consciousness, and human capability. If ancient cultures achieved this level of astronomical precision, how did they do it? And what other capacities might we be overlooking or disregarding? How might this suppression of inquiry be linked to the suppression of indigenous cultural systems, traditions, and histories? Research by Hayden and Villanueva found that most modern hunter-gatherer groups maintain sophisticated astronomical knowledge. The more complex the society, the more likely they are to track solstices and equinoxes precisely. We even have evidence from the Upper Paleolithic period, cave paintings and carved artifacts that appear to track lunar cycles and stellar patterns. Alexander Marshak identified carved bones from 30,000 years ago that seem to function as lunar calendars. This suggests that careful celestial observation wasn't an exception. It was a fundamental human capability that we've systematically underestimated. We're talking about cognitive capabilities that existed throughout human history. If Paleolithic humans were tracking lunar cycles, why wouldn't they eventually notice precessional shifts? The answer may lie in understanding consciousness itself as fundamental to reality, something ancient peoples may have recognized as a deep interconnectedness through their direct experience. Recent research into consciousness by neuroscientists like Donald Hoffman, Ian McGilchrist, and computer scientist Bernardo Kastrup supports this possibility, suggesting our ancestors' experiential understanding of reality's interconnected nature might have opened ways of knowing that our current materialist framework struggles to acknowledge. Is it possible they understood the intimate connection between cosmos, individual awareness, and even sustainable civilization? Did they develop ancient wisdom traditions that integrated spiritual sensitivity with environmental harmony, precisely what we need to address today's climate crisis and social fragmentation? So I'm curious, when you look at these findings, the statistical odds of 1 in 140 million versus just 1 in 2 million needed for statistical significance, The mathematical precision of precessional cycles, the global knowledge network spanning millennia. Do you see evidence of ancient wisdom traditions? Do those traditions suggest the possibility of systems of knowing, being, and doing that transcend a simple three-dimensional material world? Or do you think this is all an extraordinary series of coincidences? Make no mistake, this may be more than just about rewriting history books. It seems ancient cultures that understood precession developed sustainable, oftentimes egalitarian societies that lasted millennia. They found ways to balance individual fulfillment with collective survival. They developed what Western science would conceptualize as a consciousness-first worldview, idealism, that offered practical pathways for transcending the limitations of reductionist thinking that created many of our current global crises. We're not just rediscovering ancient history, we're uncovering wisdom essential for our future. And if this research intrigues you, there's so much more to explore. Check out the full Pillar 43 analysis in the video linked below. Like the video, subscribe, and hit the notification bell because the Younger Dryas Impact Hypothesis video is coming soon. And I'm excited to hear how your mind connects with this. Let me know your take on the evidence. Are we looking at proof that our ancestors' capabilities far exceeded mainstream assumptions? Or do you see other explanations for these extraordinary correlations? The more we investigate ancient civilizations through this lens, the more we discover capabilities that challenge everything archaeology and history tell us about our past. But are we ready to expand our understanding of human potential and learn from our ancestral, integrated approach to consciousness, cosmos, and civilization? Thanks so much for watching, and I hope to see you in the next investigation into our extraordinary shared heritage.